So welcome back. So the first question that we have here, this is the miscellaneous exercise on chapter 13. So the first question that we have here, you want to find the derivative of these functions from the first principle. So for example, suppose that your function is f of x is equal to negative x. So if your function is negative x, so the first principle was basically we said that f prime of x is equal to the limit of f of x plus h minus f of x over h as h tends to 0. So then you have f of x plus h here is equal to negative x plus h, which is equal to negative x minus h. So your f prime of x is equal to the limit of negative x minus h minus x over h as h tends to 0. And as h tends to 0. So if you cancel out, so then you can write this as the limit of negative 2x minus h over h as x tends to 0. Okay, so I made a mistake over here, and that is basically here you're supposed to have minus f of x, and since f of x is equal to negative x minus f of x is equal to positive x, and then you will get basically x and x will cancel out, and then h and h will cancel out, so you'll have the limit of negative 1 as h tends to 0. So the limit of negative 1 as h tends to 0 is equal to, of course, as the limit of negative 1 as h tends to 0 is equal to negative 1. And as you can see, this is negative 1. It's basically the slope of this line. At any point on the line, the slope of the line is negative 1. So that is the derivative of the line as well, meaning that f prime of x is equal to negative 1. And one more thing that you can see here is that basically usually when you have some function f of x, when you have some function f of x, f prime of x, when you calculate f prime of x, you will have some power of x over here. For example, x raised to power 1 or x raised to power 2, x raised to power 3, with some number multiplied by x or added to x and so on and so forth. But x is almost always present. almost unless for except for the case where basically you're taking, for example, the derivative of a straight line. You see, the derivative of a straight line, when you have this straight line, for example, f of x is equal to negative x, would be this line over here. The slope of this line at any point is negative 1. So then it doesn't matter which point you pick on the line, the slope is negative 1. And what that means is that you don't really need the variable anymore, because the slope is not changing. It's always negative 1. But suppose that, for example, you have some function, for example, some function like this. F of x is equal to x squared. You see that basically on this graph, it's not a straight line, it's a curved line. And on a curved line, basically what happens is that the slope is changing. So at any point, the derivative is going to be different and different and different and different. So the slope is not constant. Since the slope is not constant, when I calculate f prime of x here, in the case of this function, I will get 2 times x. And you see you have x over here, meaning that now at any point the slope is going to change. For example, if I put x is equal to 1, the derivative is going to be 2 times 1 is equal to 2. If I put x is equal to 2, the derivative is 4. If I put x is equal to 3, the derivative is 6, and so on and so forth. That means that depending on the values of x, the slope is changing because, of course, well, the slope is changing, and you can see that if you take a look at the graph of the function as well. But when you take the derivative of a function with a straight line, so when for example, when the slope of the line is negative 1 and it's a straight line, this negative 1 is the slope of the line at any point. So then, of course, you won't get any x in your derivative anymore, as you can see here, because the slope is not changing, so the x is not required here, because this is not supposed to change anymore. It remains a negative 1 all throughout your function. So that's basically that. And of course, if you were to take the derivative of this function using, we said that if you have f of x is equal to basically x raised to the power n, then f prime of x is going to be n times x raised to the power n minus 1. So then if your f of x is equal to, for example, negative x, then f prime of x is equal to basically negative, so 1, basically 1 is, you have a 1 over here, 1 is multiplied here, is negative 1 into x raised to the power 1 minus 1, which is equal to negative 1 into x raised to the power 0, which is equal to negative 1. So that is basically how you find the derivative of this function using the formulas that we have. Or suppose that you have, for example, you have your f of x is equal to negative x raised to the power negative 1. So in the case of this function, basically what you can do is that you can write this as negative x, or you can write it as 1 over negative x raised to the power positive 1. So the exponent negative 1 becomes positive 1 if your x goes to the denominator. or you can just simply write this as 1 over x, 1 over negative x. So now if your function is basically 1 over negative x, and if you want to calculate the derivative of the function based on the first principle, we said that f prime of x is equal to the limit of f of x plus h minus f of x over h as h tends to 0. Now in this case f of x plus h, f of x plus h is equal to 1 over negative of x plus h, which is equal to, well, 1 over x plus h. I can write it as 1 over negative x minus h. Okay, so f of x plus h basically becomes this thing over here. Now we said that f prime of x is equal to the limit of f of x plus h, which is basically this fraction over here, 1 over negative x negative h minus f of x. So f of x is negative 1 over x, or 1 over negative x. So you have a negative sign over here, negative into negative is positive, so plus basically 1 over x over h as h tends to 0. So you can, now if you simplify this, what you will get is basically the limit of negative x negative h times x, and then if you multiply these, you will get basically x plus negative x negative h negative x negative h over h as h tends to 0. And x and x you can cancel out, and of course you can write this as the limit of basically negative h over h times x times negative x negative h as h tends to 0, and then h and h you can cancel out. So now if you simplify this, what you will get is basically, now as h tends to 0, this becomes 1 over, so x remains x, and h goes to 0, so this becomes negative x, and you have a negative 1 over here. So then this becomes basically the negative and negative you can cancel out, you have 1 over x squared. So that means that when you have f of x is equal to 1 over negative x, meaning that d by dx of 1 over negative x is equal to 1 over x squared. Now if you use the product rule the quotient rule to calculate the derivative of this, the quotient rule is u by v whole prime is equal to u prime times v minus u v prime over v squared. So of course u prime over here is 0, so this part is really not required here, because in the numerator you have a constant, But then you can use these two parts in order to find the derivative of, for example, negative 1 over x, for example. To find the derivative of negative 1 over x. So I can write this as basically negative u, which is negative of negative 1 over times v squared, which is the derivative of x, which is equal to 1 over v squared over x squared. So this becomes basically 1 over x squared, which is basically what we have gotten over here. So now suppose that the function that you have is sine of x plus 1. Sine of x plus 1. F of x is equal to sine of x plus 1. Now sine of x plus 1 okay, so again, f prime of x is equal to the limit of basically f of x plus h minus f of x over h as h tends to 0. So over here, f of x plus h is equal to basically sine of x is equal to basically I have to set x plus h plus 1 and so f prime of x is equal to the limit of f of x plus h, which is sine of x plus h plus 1 minus f of x, which is minus sine of x plus 1 over h as h tends to 0. So now you have basically what you have here is the sine x minus sine y. Now you know that sine x minus sine y is equal to 2 times cos x plus y divided by 2 times sine of x minus y divided by 2. Sine of x minus y divided by 2. So I can write this as the limit of okay, so now basically here I can write, instead of sine x minus sine y, I can write 2 times cos x plus y divided by 2, which is basically x plus h plus 1 plus x plus 1 divided by 2, which is 2x plus h plus 2 divided by 2. So that is 2x plus h plus 2 divided by 2. And then I have sine x minus y divided by 2, which is x plus h plus 1 minus x minus 1 divided by 2. And that is basically h divided by 2 over h, as h tends to 0. So then you can write this as the limit of sine h divided by 2 divided by h divided by 2. This you can write as h divided by 2 as h tends to 0. Okay, so now I don't really know where I was. So the 2 times cos of this times sine of this divided by h. And okay, so now what I can do is that I can write this as the limit of sine h divided by 2 divided by h divided by 2. You can bring this 2 down over here and make it h divided by 2 as h tends to 0 times the limit of cos of 2x plus h plus 2 divided by 2 as h tends to 0. As h tends to 0. So we said that basically the sine of, the limit of, we said that the limit of basically sine x by x when x tends to 0 is equal to 1. So this whole thing becomes 1, and the limit of cos of 2x plus h plus 2 divided by 2 is equal to basically, if h tends to 0, then this h becomes 0, so then you will get cos of 2x plus 2 divided by 2, which is equal to cos of basically x plus 1. Cos of x plus 1. So what that means is that if basically d by dx of sine of x plus 1 what that means is that d by dx of sine of x plus 1 is equal to cos of x plus 1. And of course you know that this d by dx of sine x is equal to cos x. So now let's check the answer here. Number cos of x plus 1. So the next question that we have is you want to find the derivative of, let's say that for example your f of x is equal to cos of x minus pi by 8. X minus pi by 8. Now So basically, if your f of x is equal to x minus pi by 8, then you can say that, of course, and you want to use the first principle. So you want to basically d by dx of f of x, d by dx of f of x is equal to the limit of f of x, the limit of basically f of x plus h minus f of x over h as h tends to 0, So over here, f of x plus h is equal to basically cos of x plus h minus pi by 8. So then you can say that d by dx of f of x, which is equal to f prime of x, is equal to the limit of basically f of x plus h, which is cos of x plus h minus pi by 8, minus f of x, which is cos of x minus pi by 8, divided by h as h tends to 0. And basically over here what you have is cos x minus cos y, for example. You can think of this as cos x minus cos y, which is equal to negative 2 times sine x plus y divided by 2 times sine of x minus y divided by 2. So you can write this as the limit of negative 2 times sine x plus y divided by 2 becomes this plus this divided by 2. So that is x plus h minus pi by 8 plus x minus pi by 8, which is equal to, so this divided by 2, which is equal to 2x, this is 2x, and this is negative 2 pi by 8 plus x plus h divided by divided by 2, which is equal to 2x minus 2 pi by 8 is minus negative pi by 4 plus h divided by 2. So that would be basically 2x minus pi by 4 plus h divided by 2. Okay, and then the next part is sine of x minus y divided by 2. So times sine of x minus y. So that is x plus h minus pi by 8 minus y, which is negative x plus pi by 8. The negative is multiplied by both of these. And then you divide that by 2 basically. So that is, then these 2 will cancel out, that is h divided by 2. So that's sine of h divided by 2 over h as h tends to 0. So I can write this as the limit of basically sine of h, sine h divided by 2 this negative sign, I can take it out. So that's a negative limit of, basically, negative limit of sine h divided by 2 divided by h divided by 2 times, basically, sine 2x minus pi by 4 plus h divided by 2 as h tends to 0. So again, we said that basically, the limit of sine x divided by x when x tends to 0 is equal to 1. So I can write this as the negative of the limit of sine h divided by 2 over h divided by 2 as h tends to 0 times the limit of sine 2x minus pi by 4 plus h divided by 2 as h tends to 0. And so this part is equal to 1. This part is equal to negative 1 actually, times now the limit of h tends to 0 of sine of this angle is basically 2x minus pi by 4 divided by 2. So that would be sine of 2x minus pi by 4 divided by 2. So that is equal to the negative of sine of basically x minus pi by 8. X minus pi by 8. And that's basically that. So that means that d by dx of cos of x minus pi by 8 is equal to d by dx of cos of x minus pi by 8 is equal to negative sine of x minus pi by 8. And of course you already know that d by dx of cos x is equal to negative sine x. So everything fits together in the most beautiful way ever possible. It's like magic. Okay, so the next question that we have, so the next question that we have is basically a couple of functions, and in these functions it is to be understood that basically these variables like a, b, c, d, p, q, r, s, p, q, r, and s are fixed non-zero constants. These are fixed non-zero constants, and so these are fixed non-zero constants, meaning that they could be negative or positive but not zero, and m and n are integers. So an integer could be a zero as well. So for example, if you have basically if you have the derivative of, for example, let's say that you want to find the derivative of d by dx of x plus a, that means that you have basically x over here and some non-zero constant over here, for example, something like, for example, x plus 2, something like that, for example. So So in this case, in order to find the derivative of this function, so of course you can write this as basically d by dx of x plus d by dx of a, which is equal to actually I need to go back here. d by dx of x minus d by dx of a, and so what that is basically, d by dx of x of course is equal to 1, and d by dx of a is equal to 0. That is equal to 0. So that's equal to 1. So number 2 is 1. And number 3, for example, suppose you have basically you want to find the derivative of, you want to find d by dx of px plus q times r over x plus s. So we said that p, q, r, and s are non-zero fixed constants. So non-zero fixed constants means that they're not zero. So of course then d by dx of px plus q times rx plus s is something like, for example, 2x plus 3, for example, times for example 2 by x divided 2 by x plus 5, for example. Of course, just take this as, for example, 1 over x, for example, plus 5. And how would you find the derivative of this function? To find the derivative of this function, you would use the product rule. So the product rule tells you that basically u times v whole prime is equal to u prime times v plus uv prime. And then you would first take the derivative of this function times the second function plus the first function times the derivative of the second function. So that's basically how you would do it. Now coming back to the example up here, so then you would write this as d by dx of basically px plus q times the second function r over x plus s over s, r over x plus s, and plus basically the first function, which is px plus q times d by dx of the second function, which is r times r over x plus s. Now I don't know how much I need to simplify this thing. Let me see. Number 3. I suppose all the way through. So then d by dx of px plus q is equal to, for example, if you had d by dx of px plus q, you would write this as d by dx of px plus d by dx of q. Now d by dx of px is equal to p. D by dx of q is equal to this is some constant, for example, d by dx of 2 is equal to 0. So this would be just a p. So then this would be basically p times r over x plus s plus px plus q times d by dx of r over x plus s. So for this part, what you need to do is, when you have d by dx of when you have d by dx of r over x plus s, so of course this is equal to d by dx of r over x plus d by dx of s, d by dx of s. So d by dx of r over x, for this you can use the quotient rule. And the quotient rule tells you that basically u divided by v whole prime is equal to u prime times v minus u v prime over v squared. Now you can see that u prime over here, if I'm talking about basically this part over here, your u prime would be 0 because this is a constant. Since this is a constant, the derivative of a constant is basically 0. So then you can just simply forget about this part and then just simply calculate this part. So then you can write this as negative u, so this is negative r times v prime. V prime is the derivative of x, which is equal to 1. And the denominator is v squared. So v squared is x squared. Plus d by dx of s is equal to basically the derivative of some the derivative of some constant, which is equal to 0. So that's equal to negative r over x squared. Negative r over x squared. So that is negative r over x squared. Now what you can do here is, I don't know, probably just I can write this as PR over X plus PS plus or minus PRX divided by X squared minus RQ over X squared minus RQ over X squared, and then X and X can cancel out here. Okay, so this is PR over X, this is PR over X. So this is 2 times PR over X. 2 times PR over X. So these two, no, actually this will be cancelled out. This will be cancelled out. This is negative PR over X, this is PR over X, so these two will be cancelled out. So you have PS. So you have PS minus RQ over X squared and so that's equal to basically X squared, and you can write this as probably, I don't know, let me see how they have written this. Number 3 is negative QR over x squared plus ps. That's basically how they have written this as well. I'm not going to, basically that's the final answer. So that means that basically if you have some function, basically non-zero, basically provided that p, q, r, and s, p, q, r, and s are non-zero constants, then d by dx of px plus q times r over x plus s. Maybe sometimes, basically in some situation you could use this formula, although r over x plus s is equal to p times s minus p times s minus rq over x squared minus rq over x squared minus rq over x squared. Okay. Anyway, I don't really think that you're going to even take a note over here or send this to your notes or anything like that. So that was number 3. And number 4, suppose that you have ax plus b times cx plus d whole squared. So what happens there? Okay, so now in order to take the derivative of this function, what you can do is that basically based on the Leibniz product rule, you know that u times v whole prime is equal to u prime times v plus uv prime. So then d by dx of this function is equal to d by dx of ax plus b times cx plus d whole squared. So d by dx of this function times this function, and then you have basically u times meaning plus ax plus b times d by dx of the derivative of the second function, cx plus d whole squared. Now the d by dx of ax plus b is just a, because well, you know that d by dx of ax plus b, so this is just a constant. They can write it as d by dx of ax plus d by dx of b, which is equal to a plus 0, which is equal to a. So this is just equal to a times cx plus d whole squared plus ax plus ax plus b times the derivative of cx plus d by dx of cx plus d whole squared, of course. So of course there is some formula for this, but we haven't derived the formula yet. Otherwise we could just simply use the formula. But since we don't have the formula, what we can do is that we can write this as d by dx of basically c squared x squared plus d squared plus 2 times c dx. And of course you know that basically d by dx of this function is equal to d by dx of c squared x squared plus d by dx of d squared plus d by dx of 2 times c dx. Now d by dx of c squared x squared is the same thing as so over here what you need to do is, again, you have the product rule, meaning that you have to basically take the product rule is u times v whole prime is equal to u prime times v plus u times v prime. Now since c squared is just basically a constant, so this term goes to 0 because u prime is going to be equal to 0. So then you have only u times v prime. So u times v prime would be c squared times so that means that d by dx of c squared times x squared is equal to c squared times d by dx of x squared. And you know that d by dx of x squared is equal to 2x, so that's c squared times 2x, which is equal to 2c squared x. So that is 2 times c squared x. And of course you know that the derivative of a constant is 0. The derivative of a constant is 0. So that would be plus 0, and basically if I take 2cd as a constant, the constant times a function, the derivative of 2cd times x is just equal to 2 times cd, the constant or the slope of the line. So that's basically 2c squared times x plus 2cd. So over here you have ax times b times 2c squared times x plus 2cd. Plus 2 times cd. And I don't know if it's necessary to number 4. So we have ax plus b times 2c times cx plus d. So you can take over here, you can write this as a times cx plus d whole squared plus ax plus b times, now over here 2 times, over here 2 times c squared times x plus 2 times cd. You can take a 2c out, and then cx plus d. So I can write this as basically ax plus b times cx plus d times 2c. And that is basically the final answer. So you have basically 2 times c times cx plus d times ax plus b plus a times cx plus d whole squared. That's your final answer. So there's another question number 5 here, but that we will do in the next video.